Okay, we're going to be talking about alkanes in this presentation. The most important thing to note about alkanes is they have no functional groups. Now, a functional group is any part of a molecule that is not carbon-carbon single bonds or carbon-hydrogen. So if you look at an alkane, you'll see it's all carbon-carbon single bonds, and all the carbons are completely saturated with hydrogen, meaning to give it 4 bonds, as many hydrogens as possible are put on there. All the carbons have 4 bonds, and there are not going to be any double bonds. So the number of hydrogens is always the number of carbons, or 4 minus the number of carbons attached to that carbon. The functional groups give compounds physical properties. So the physical properties of alkanes are very simple. They're just oily. Although the low number carbon alkanes, those that are 4 carbons and below, are gases, but they're an oily gas. The functional groups give the reactivity to the molecules, and so with no functional groups you have very little reactivity, almost no reactivity. The functional groups that you're going to need to know for the first exam are going to be very limited. Alkenes will be one functional group that you need to know, and they are those compounds that have a carbon-carbon double bond. Alkynes are those that have a carbon-carbon triple bond. Arenes, they're really the aromatic compounds. They have alternating carbon single bonds with carbon double bonds and a 6-membered ring, but I'm not going to test you on that. Okay, here's some more functional groups. You don't have to worry about the phosphate functional group or the ether functional group. I'm not going to be testing you on those functional groups in this first exam, but you will be tested on an alcohol functional group. What is an alcohol? An alcohol has a hydroxyl group on it, or a hydroxy group on it. That's not hydroxide, it's hydroxyl. And it's attached to a carbon that has no double bond on it. So if there's a double bond to an oxygen there, it's a different functional group. The halogens are kind of considered a functional group and kind of considered just a substituent. It's no big deal at this time. I'm not going to test you on that as a functional group. They are more reactive than a substituent, much more reactive than a substituent, but they are considered a minor functional group. Now, there's many functional groups that have carbonyls in them. Most of these you are not going to be tested on this first exam. The only ones that you're tested on are going to be the aldehydes, ketones, and carboxylic acids. Now, to differentiate between them, aldehydes have a carbon-oxygen double bond, and notice there's a hydrogen attached. Ketones have a carbon-oxygen double bond, but on either side there are carbons attached. Carboxylic acids have a carbon-oxygen double bond, but attached to them is what looks like a hydroxyl group. This looks like 2 functional groups on 1 carbon. Whenever you have 2 functional groups on 1 carbon, which all of these down here have, but whenever you have what looks like 2 functional groups on 1 carbon, it's really 1 functional group, and they operate as a unit. They never operate separately. So these 3 functional groups you will need to recognize. So here are all the functional groups that you need to know for your first exam, and you need to be able to recognize them in various molecules. There's plenty of problems in your book to try out, and if you look at some of the old exams, you'll find problems on these also. Okay, the alkanes, again, have no functional group. They can be straight-chained or branched. Right here are some straight-chained ones: methane, ethane, propane, butane. These are called saturated. Saturated means no double bonds. The carbons have as many hydrogens as possible. Another way of describing alkanes is to say aliphatic, meaning there are no double bonds. Now, what we find is that all the alkanes have the same general formula of CN H2N plus 2. What this comes from is if we look at an alkane, you'll see that in a straight chain alkane, every single carbon has 2 hydrogens on it, but the 2 N carbons have extra hydrogens on them, and that is what gives this plus 2. This is a very useful general formula to use because if you count the carbons and you see there's no double bonds and no rings, you know that this formula applies and you know the number of hydrogens automatically. Isomers are compounds that have the same formula, but they are different compounds. They have different names, different structures. These are called constitutional isomers because they differ in connectivity. If I go down here and I look at this, you will see there's a carbon that's connected to 3 carbons. There are no carbons here connected to 3 carbons. So the connectivity is different. So butane right here is called an isomer of methylpropane. Butane is what's called a normal or a straight chain alkane, and methylpropane is called a branch chain. It has a substituent on it, the methyl group. Here's an example of some more constitutional isomers. That constitutional is misspelled, isn't it? If I look at ethanol, I can see that it has 2 carbons, 6 hydrogens, and an oxygen. If I look at the dimethyl ether, it's 2 carbons, 6 hydrogens, and an oxygen. So they have the same formula, which isomers must have. But if I look, they're connected differently. Here the oxygen is on the outside, and over here it's on the inside. If I look at isopropylamine, again, 3 carbons, there are 9 hydrogens. Over here, 3 carbons and 9 hydrogens. This has the same formula as this, but you can see the connectivity is different. The nitrogen is connected to the middle carbon here. The nitrogen is connected to the N carbon here. One thing left to cover on this that I didn't mention is unrelated. When you have unrelated compounds, what you have is a compound, 2 compounds that have different formulas. When they have different formulas, they're going to be unrelated. Condensed structures. What are condensed structures? This is a way of writing a structure so that we don't have to show all the bonds. We can write a structural formula like this, or even like this, but that takes a long time, and butane right here is a very small molecule. So what must we do? What we do is we write it in groups. See this group, notice it's only the carbon bound to the carbon, but we can write CH3 for that, right there. And we can write CH2 for this. And we can write CH2 for this. And we can write CH3 for this. And so that is one way to write a condensed formula. You can also smash them all together so you don't show the bonds. That's valid also. Another way that we don't do unless we have a really long chain, we usually don't do it for butane, but we'll do it for when we have like 10 carbons. We'll write the end, CH3, and then we'll write all the carbons in between that have 2 hydrogens attached, and we'll just say how many there are strung together, and then end with the CH3. So you will see this